Okay, in lesson 2.4, this is problem number 6, which is similar to problem number 7, and it works basically the same way. So there's slight differences, but the process is basically the same. So um, if we, now in the past, if we substituted 1 in for our limit, we get 1 minus 1 is 0. And 1 squared minus 1, that's 0, so we get 0 over 0, so we can't just substitute 1 in. Well, in the past, the other problems that we worked with, they were going to infinity, so you can't use 1 over whatever the highest power of x is over itself, like we could in the previous problems, because um, these don't go to infinity, so they're not going to get, as x gets larger and larger and larger, they're not going to go to 0. So what we have to do is first see if we can substitute in. Cannot. So the next thing we want to do is see if we can simplify. Well, we have x, in other words, if we can factor and then cancel. Well, here we have x minus 1. Well, we have a difference of 2 squares here in the radicand, so we can say, all right, this is the limit as x approaches 1 from the right for x minus 1 over, and then square root x squared minus 1, we can say, all right, well, we can make that a 1 squared, because 1 times 1 is still 1, so we can make that a difference of 2 squares. So we can say, all right, x, so that's x squared minus 1 squared, factor the difference of 2 squares, that would be x minus 1 times x plus 1. All right, well, we're getting closer to being able to simplify this, but the problem here is we have this x minus 1 inside a radical, so we can't just cancel them. So but what we can do is convert this radical to an exponent and then use properties of exponents to simplify that way. So let's review properties of exponents real quick. We know that the nth root of a is the same as a to the 1 over n power. So whatever this root is, that's, you're going to change this to a rational exponent where the denominator is the same number as your root. Well, in the square root, we normally don't write 2 there, but that's our root. So in that case, we can change this radical to the limit of x approaches 1 from the right for x minus 1 over, and then change this radical to x minus 1 times x plus 1 to all to the 1/2 power. So this radical is now this expression to the 1/2 power. Okay, another property of exponents is a b to the n power is a to the n times b to the n. Well, this x minus 1, that's 1. That's like your a. This x plus 1, that's like your b. So we can distribute this exponent to each expression outside of each of the parentheses. So that's the limit. X approaches 1 from the right is x minus 1 over x minus 1 to the 1/2 power times x plus 1 to the 1/2 power. Okay, we're getting closer now to being able to simplify this. Well, the problem here is this is a has an exponent of 1, and this has exponent of 1/2. The bases are the same. So that's like saying a to the 1 over a to the 1/2 is, let me use red. If we said a to the 1 over a to the 1/2, we could say, all right, well, that's the same thing as saying a to the 1 minus 1/2, because we're dividing bases, so we subtract the exponents. Well, we can change that. So that's what we want to do here. So we write this as the limit, that up, limit as x approaches 1 from the right of x minus 1 to the 1 minus 1/2. So that's these two, 1 minus 1/2 over x plus 1 to the 1/2. Okay, well, we can change this 1 to where we have a common denominator. So that's the limit as x approaches 1 from the right. So that would be 1 minus 1/2. Well, you know, that's just 1/2, right? X minus 1 to the 1/2 power over x plus 1 to the 1/2 power. Okay, now from here we can go ahead and apply our limit. So this would become 1 minus 1 to the 1/2 power over 1 plus 1 to the 1/2 power. Well, 1 minus 1 is 0 to the 1/2 power. 0 to 1/2 is just 0 over 2 to the 1/2 power. Okay, now a review of rational numbers. 0 over any number is 0. Any number over 0, that's undefined. Since this is 0 over 2 to the 1/2 power, that's just 0. And that's our answer. But if you ever get a problem like this, where you get a 0 in the denominator, then it's not defined, or the limit does not exist, or in other words, it continues on to infinity, because the limit doesn't exist, it goes on to infinity, and that would be infinity. Since this is approaching, you would have to look on your calculator, see if it's going to be positive infinity or negative infinity. So our answer here for number 6 is 0. Okay, number 7, you're going to work it basically the same way. Okay, and so if we wanted to check it on the calculator, here it is. We would put in parentheses x minus 1, close it, divided by square root of x squared minus 1, close it, graph. So as we can see, as the limit, as we approach the function from the right, it goes to 0. And that's our answer. And so please let me know if you have any questions, and have a great day.